Greetings everyone, and welcome to this video in my lecture series on binary, octal, and hexadecimal numbers. In this video, we are going to convert decimal or base 10 numbers, which are integers, to other bases being binary, octal, and hexadecimal, though you can actually use any other base that you like. Before we do that, let's recall that if you're converting from octal to decimal, you can do that by using the expansion method, where we write 152 base 8 as 1 times 8 squared plus 5 times 8 to the 1 plus 2 times 8 to the 0. And if you plug that into your calculator, you'll get 106 base 10. You could write that actually as the 106 base 10, but it's okay in this instance to leave off the subscript because the default is our base 10 numbering system. Now, since we've done that, we've converted from octal to decimal. The question is, can we go back the other way? If we are given the number 106 base 10, how do we get that number back into octal? We can't use this expansion method to go the other way. The method we're going to use is repeated division, where we take the number 106 and we're going to repeatedly divide by the base, which is 8. Now, in order to make this nice and tidy, I'm going to set it up in the following way. I'm going to take 106 and divide it by 8, and then write it as, a little half box here, where I've got Q and R at the top, where Q is the quotient and R is the remainder. So 106 divided by 8 gives 13.25. So the 13 goes under the quotient, so you take the integer part, goes into the Q column, and then you take the 0.25 part and you write it as the remainder. Now the remainder is a whole number, so you take the 0.25, multiply it by 8 to get 2. Now take the quotient here, the 13, write it below, and divide that by 8, and 13 divided by 8 gives 1.625. Write the 1 part, the integer part, in the Q column. Take the fractional part, or the decimal part, the 0.625, multiply it by 8, and that will give you a 5 in the remainder column. Now again, take the quotient here, write it below, and we're going to have 1 divided by 8. 1 divided by 8, well, hopefully you can tell by looking that 8 doesn't go into 1 evenly at all, so we're going to get a quotient of 0, and what's left over? Well, just the 1. But if you're having one of those days, you can actually take 1 divided by 8, get 0.125, multiply it by 8 again to get 1, and go, oh yeah, that thing. So, for this method, you keep dividing until Q equals 0. Once you've done that, you take your remainders and you write the digits in reverse order. And from that we can conclude that 106 base 10 is equal to 152 base 8. And if you go back and look at the beginning of the video, we had converted 152 base 8 to get 106 base 10, and so we're quite satisfied that we know how this works. We can now convert back and forward between the octal system and the decimal system.